clapping. Everyone clap with me. Kelsey's first. So Kelsey's going first. This is Kelsey. Hello. I'm going to take my position here.
So like heart pounding right now. Everything good so far, guys?
Yeah.
Cool. No, it's not part of my time. Whoever said that.
Okay, let's go.
Hola. Huzzah. My name is Kelsey Iverson, an engineer on the research and development team at Illuminati Missoula, and I'm on a mission to educate about something that affects every user of the internet: pixels. In 1994, cookies were developed for the first time by Lou Montouille, an employee of Netscape Communications, as a solution to make e-commerce storing state on the browser possible. Fast forward to now, enter Carly, cruising to a secret camping spot on the Gallatin in her old Ford Bronco. She's hearing many odd sounds. After thousands in repairs for the vehicle, she knows the old girl is breaking down. She wants a new adventure mobile, and she's looking for the most fuel-efficient SUV on the market. Enter Subaru of Paradise Valley. Very small shop, audience of Bozemanites. They will be doing their homework, so Subaru of Paradise Valley wants to stay on top of their shoppers' minds as they do their research on these vehicles. Carly hops on her computer. Her friends say there's a helpful and trustworthy person out at the Subaru dealership in Paradise Valley. When Googling, she clicks on the website and starts browsing through their available cars. Luckily, Subaru Paradise Valley has planned ahead. They have chosen to set up their marketing strategy through the platform Campaign Manager, one of hundreds of options to do their marketing through. They generate 10 code snippets called pixels that then embed in the HTML of their website. As Carly clicks around through certain buttons, visits certain landing pages, these pixels fire and drop cookies onto her browser. What is a tracking pixel? There's many names for this. This is a tag, a snippet, a pixel, a floodlight activity. A tracking pixel is a little piece of JavaScript code containing an image, a 1x1 pixel, which is where the name comes from, that usually hides on button clicks or different page views. In this case, it drops a cookie when fired. What is a cookie? You can find cookies on your browser by clicking the little box, or the little lock box, to see them. They're a string of numbers and letters. They are passive variables only, to be read by the platform in which they came only. So in this case, that was Campaign Manager. Facebook will not be able to read this. This string will be looked for later, and stored locally on your machine. Carly closes Subaru's website, goes about her search. Days go by, she watches a couple YouTube videos, reviews different cars, Googles her friends' hints, and finally lands on a BuzzFeed article on the 22 most fuel-efficient SUVs. As BuzzFeed's page starts to load, something amazing happens. The secret, silent, split-second auction. It's not that secret, but it's interesting. This could take another hour to explain everything that happens in an eighth of a second. But essentially, BuzzFeed decides to reserve empty boxes through their page. When Carly's browser starts to load the page, hits these spots in HTML, the code fires to an ad exchange to retrieve an ad. This box is reserved, in this case, for real-time bidding allocation. The ad exchange then fires something called a cookie sync. This is another fascinating parallel process that we could have an entire conference on in all the different technology companies that are involved in this. All you need to remember is each platform can only see its own cookies, and for every ad served through real-time bidding, about 10 times as many technology companies are involved in the cookie sync process. Again, marketer site, Subaru, user goes there first, blah, 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 and then it piggybacks to get back to BuzzFeed. Millions of potential ads are being considered in the split-second auction of this webpage. I'm not kidding, millions. This is all happening very quickly. As BuzzFeed makes its money best when selling this ad spot to the highest bidder, if advertisers are smart, they will strategize and set parameters on this bid, paying only for their highest potential buyers. Subaru Paradise Valley has done this. Users got to the Forrester page, a cookie was sent, have been to their site more than once, more cookies are sent within 80-mile radius of Paradise Valley, most likely Bozeman, and are currently browsing blogs for fuel-efficient SUVs. All this checks out. Subaru's DSP campaign manager is alerted that there's an anonymous buyer with exactly these parameters as Carly is searching. Subaru set a predetermined amount to pay for this user's attention thanks to Carly's cookies, and out of millions of advertisers, Subaru Paradise Valley was able to win the bid. And their ad is served on BuzzFeed's empty ad spot to Carly. This process will continue as Carly browses more sites, racking up more and more cookies, firing more pixels, all defining her as a certain type of user. Again, we're just touching on tracking pixels and cookies here, which usually have a shorter lifespan, but there's many other types of cookies, including things called persistent cookies. Check those out. As this landscape changes, we all have the responsibility as users of the internet to grow and adapt with it. I'm reminded of a Mad Men episode. The marketing campaign working for the Kennedy side was talking about buying up all the commercial TV space in swing states and showing them soap ads. Has nothing to do with Kennedy, has nothing to do with Nixon, but it's in the swing states the most important airtime, and they bought it all up and showed them soap. If our small businesses and politicians alike can identify you as a certain type of user and purchase your attention at the highest bid, showing you exactly what they think will sway you into their direction however they want to, this could and has drastic ripple effects in our culture. Marketing will never go away. It's not all bad. But if you occasionally clear your history, keep an eye on your Facebook preferences, and you can make cookies and pixels work for you. Pure luck, even had it at once. I was categorized on Facebook as an adventurous Norwegian and was served an ad for apply now to a Norwegian adventure race, which I actually got on. That's another slideshow. My point is simply, be educated, educate your loved ones, especially the older cultures and older generations that don't understand this, and use your analytical brains around this space, being involved in the conversation. Thanks.
I am so glad to be here with my people. We, the geeks, the introverts, we don't like touching others, so let's all give ourselves a little hug. My name is Brady Wiseman. I'm with Oracle, and I'm here today to talk to you about infrastructure as code. No PowerPoint. Let's all work together and use our imaginations. You ready? All right. My team is involved with rolling out computing environments on the new Oracle Cloud infrastructure. Oracle is standing up a large new public cloud to compete directly with Amazon and Google and Azure. And you heard about it here first. So we are involved with standing up these computing environments. We have development environments, we have staging environments, we have production environments, and they're all the same. Same architecture, same structures, same networking. So how do we do that? How do we make that happen? Well, we use infrastructure as code. So we can stand them up in US West, US East, London, Frankfurt, coming soon, Tokyo, Sydney, around the world, blah, blah, blah. So how do we do that? Well, we have code. We have Terraform, we have Ansible. So work with me here and let's roll one out. I've got a code repo. It's got a ton of configuration in it with Terraform and Ansible. We're going to pull that down on a terminal, and we're going to roll it out onto our new Bozeman data center. You with me? Good. So the first thing we need is to stand up a compartment, which is kind of a namespace. So we're going to do Terraform apply. Zoom! We got a compartment. And it comes with a subnet. Our tenancy has a virtual cloud network, what Amazon calls a virtual private network. Same. And we're going to stand up put together a subnet in this compartment, which is going to contain all of our stuff. So that's great. Next thing we're going to do is stand up subcompartments, because we've got a lot of stuff we're going to put out there. I need a subcompartment for my Bastion servers, which is the interface from the outside world to all these servers. Terraform apply, zoop, I've got a compartment and a subnet to stand up those Bastion servers. I need a compartment for our databases. I need one for our Kafka cluster. Terraform apply, I've got a new compartment and a new subnet. Beautiful. I need one for our Kubernetes cluster, for our security services, for our shared services, our telemetry servers, all namespaced and subnetted. Terraform apply, up they come. All this stuff takes just a few minutes, pretty quick. The stuff that takes more time is standing up our servers. We've got a lot of servers in one of these environments. First thing we're going to do is start with our Bastions. We're going to stand up some Bastion servers. We've got Terraform apply. We're going to stand those up. This takes a while. If you've ever put together a server on Amazon, we're going to stand up a server. Our Terraform is going to run a lot of Ansible code to configure that server. We got 1, 2, 3. We're going to do DNS stuff. We're going to do networking stuff. A lot of stuff has to happen. But because we're using our imaginations, we can just do that in a few seconds. So it's done. Security services. We have a Vault cluster. We have a console cluster. We're going to run Terraform apply. We're going to stand these up. They're ready to go. I need a Prometheus cluster so I can monitor all that stuff. Terraform apply, up it comes. It's a beautiful thing. A database. Oracle has some really great database servers. Exadata. When we stand those things up, the lights dim because they're so big. But you can sort of hear them go. We need a Kafka cluster in our Kafka compartment. Same thing, we pull in our code, we run Terraform apply, up come these servers. Ansible stocks them with all of the software they need to run Kafka and Zookeeper. We've got a bunch of servers doing that. Then finally, we need a home base to run all our services. That's our Kubernetes cluster. Again, we pull in the code, we do Terraform apply, and these servers get stood up, they get configured, they get networked, and they all stand up and they run. It's fantastic. So there it is, our environment's all ready to go in our new Bozeman data center. Now, an experienced practitioner takes a little over half a day to do all that stuff. So I did gloss over a few details. We did go past some fine print because there's a lot of stuff that has to get put together. Nonetheless, it's there. We have our environment, so we can let our developers loose. We can stand up now microservices on that environment. Here, we're going to pull in another code repo with our microservices, and we're going to cut a new branch. We're going to do a little configuration, maybe add a feature. We're going to push that branch back to our code repo, and then we're going to do a merge request on that, which triggers our Jenkins build, our continuous integration build, which does all of our testing, builds Docker images, posts those out to our Artifactory repo. When we see that that comes back green, why, we can say, let's do the merge. And when we do that merge on our GitLab repo, it fires off the continuous delivery part of our pipeline, which then grabs all that stuff, runs a Helm chart, installs it on our Kubernetes cluster, and we get stuff appearing. We have a deployment, we have a replica set, we have pods. And those pods start running, they do a lot of stuff. They connect to console to do service discovery. They write some keys, they read some keys. They find the services they need. They connect to a database server and start doing stuff there. They connect to our Vault cluster to get a certificate to get to the Kafka cluster, which is all very tightly secured. And so they connect to Kafka, they're reading streams, they're processing streams, they're writing streams, they're putting stuff in the database, everything's great. We do have now a Grafana console connected to our Prometheus. When we installed that Helm chart, it also installed a Grafana dashboard. So we can look at our dashboard and check out what our service is doing. We can see the data moving, we can see our metrics. We can see, for an example, that we're getting some errors somewhere. So we can look at the pods and look at the logs on our Kubernetes pods, read the logs, see what's happening, find the error, go back to our code base, fix that stuff, push the code, push a new branch, do a continuous integration build, see that it comes back green, do the merge, do the continuous delivery part of our pipeline, do the Helm upgrade. The pods get replaced one at a time. Our data then never stops. It appears on our dashboard. Our errors stop happening. It's all happy. Our work here is done. We can take the rest of the day off.
All right, so I'm filling in for the other Rob involved with DevCon, Rob here, sorry. I don't have a very formal talk, but I did want to kind of talk about something that's a passion of mine, and that's kind of making and what I'll call tweaking or modding your everyday equipment. So I think it's very important for us as developers and creative people to kind of explore all the different things we use each day and see how can you make them better. I think one thing I'll ask first is how many people in here edit their code editor in any way? Like, it doesn't have to be editing the code, but you use Vim plugins or VS Code plugins or Sublime plugins. All right. So one of the reasons that we do that, and this is my opinion, but one of the reasons we do that is we're tailoring your code editor to your personal, individual coding style, your brain, how your brain works, trying to make it more efficient. One of the things that I think has been very empowering to me has been to kind of take that same mentality other places in my life. So how many people in here have also run a table saw? All right.
Joe?
How many people have learned how to weld? All right. How many people have learned anything about painting or drawing? All right. So I think that even though those are historically or traditionally not part of programming or tech in general, I think that there is something very similar, can be something very similar to how we interact with programs and how we modify things like our code editor or learn more about our computers and how we tweak our computers. In the same way, you can modify everyday things that you own. You know, you can build your own tools, you can build your own cabinets, you can build your own pieces of equipment. I end up modifying a bunch of things that I own, so like if you get a backpack and you don't like how the strap sits or something, you can always take the stitch ripper out and take it off and learn how to put it back together. Like, I'm not very good at using a sewing machine, but I would definitely encourage you to, you know, do something like that. I think a lot of people, especially in our community, are not scared, but are worried that they're going to go into this modifying or learning about welding or learning about woodworking tools, and they're going to feel out of place and feel like, well, that's what carpenters do, or that's what welders do. And I think that we were all in the same place when we were learning how to program at one point, and we're all in the same place learning how to use our computers at some point. So I don't think that you should be discouraged just by that you don't know how to use this tool that may even seem complicated, but compared to using Vim, like a table saw is and yes, you can do things in Vim, just saying. I actually brought up Vim because Hobbs told me I should. So. But yeah, so this is sort of part of why, in addition to Montana programmers, I'm involved with the makerspace here. I think that it can be both fulfilling and kind of encourage your programming life to also jump in and do some physical space tinkering and modification. And, yeah, that's all I got.
So this is kind of funny. I just got an introduction from Brady without even talking to him. We'll find out here in a second. Any second. Or not. Oh. So I'm talking about GitOps. So my name is Evan Locke. I'm an engineer at Onyx Maps. And it kind of really touches on the same thing Brady talked about. Who's here familiar with Kubernetes? Like everybody's heard about it, right? Cool. So you probably just heard about Terraform. Has anybody heard about Terraform before 2 minutes ago? All right, see, so the new big hotness right now is infrastructure as code, right? Like being able to manage your cluster state, manage your entire infrastructure in a singular place that everybody knows about, right? And so everybody has a new word for this. It used to be DevOps. It was ChatOps. Remember ChatOps? Yeah, let's not talk about ChatOps. DevSecOps is like a thing now, you know, like. But to me, GitOps is kind of like how DevOps enabled all those cloud processes and everything. GitOps is now bringing us towards cloud native and running things on a distributed cluster, kind of like Kubernetes. You can apply this everywhere else, but as the local Kubernetes evangelist, I don't know why you would. So just a quick timeline, you can see DevOps has been flowing forever, right? This is not a new concept and everything. It's continually evolving and whatnot. And I'm just kind of going to gloss over it here real quick. So if you're familiar with Kubernetes, there's a thing, kubectl. It's kind of like your CLI to the cluster. And traditionally, or like when you first start out, every developer just gets access to that, right? Which means you just give them the keys to the castle of your cluster. And that allows people to, you know, kind of do whatever they want to the cluster. And so you have a bunch of people making changes to the state of the cluster. You have no idea how it's, the state of it, who's tracking it. There's no peer review on it. You have security risk, like what if you give like, you know, somebody doesn't really know what they're doing, they delete the wrong thing. You can have some problems, you know? And how do you like resolve that problem when it was just Joe Schmo that applied that, you know, Prometheus cluster to it? You have no idea how it was set up. Turns out it was set up on his local machine, and he's in Tahiti, you know? You can't fix that, right? There's a ton of solutions out there that have come along this way, like templating and whatnot. Like you have Helm, Keel, SpinMaker, Jenkins. You have custom pipelines and bash scripts that are thousands of lines long. But to me, I don't really feel like they solve like the problem, you know? And so just a quick little another thing here. You can see how quickly convoluted this gets when you integrate your CD and your CI together, and you don't really have this firewall in between, right? So you have a developer pushing code up through Git, right? You have your CI that automatically runs, your pipeline runs, your tests go, everything goes green. And then at a certain point in your pipeline, there's a Helm apply, there's a kubectl apply, and there's some just thing that happens right in your pipeline. And that's just how you apply cluster points, right? Hopefully you're at that point, right? I'm going to talk about a different way of doing it. Best part about this whole process is there's like 100,000 different ways of doing this in Kubernetes, so nobody's really wrong yet. So GitOps is kind of building on this infrastructure as code, this Terraform thing, right? Your configuration is code. You're using Git to manage your cluster state. Everybody here is familiar with Git. Pull requests, permissions, you know, CI checks, peer review. Get all of that with Git for free. It's amazing. You have this unified deployment experience for like every environment you have. it enables developers to really own this system because they're familiar with Git. It's amazing, you know? And then you have these infinite updates that are verifiable, and you can look back in the Git tree and be like, oh, hey, Evan just messed this up. And that's kind of important, right? Everybody loves Git blame. So GitOps kind of builds on this, right? So you're completely under version control. You get to make pull requests. Git becomes the only place where your operations occur. When disaster strikes, you can just go to your Git repo and boom. Just like Terraform for your infrastructure, boom. You get your application code on your Kubernetes cluster straight from Git. You know, and I kind of feels like I repeated some of this before because I was up late. But developers get to own this because they know Git. It's not some fancy CLI. It's not some learning some new templating language that like nobody likes. You know, and I keep harping it, but everybody gets to see who changed it and verify it. So this is kind of the new thing, right? So you have your CI system over there. CI gets to do whatever they want. You get to separate the duties. You get to run GitOps over on the side of this. And so the only thing GitOps cares about is the new image or the new cluster state it has to deploy. And probably running out of time, so keep cruising. So CI here, you run your CI, everything happens, right? You end up pushing this new container to your registry. And at the same time, manually, or if you write some cool automation, your config repo lives separate from your application code. So say I pushed a new version, V1 to V2, right? V2 container goes up here. Now you go over here, your config repo, you say, I want to run V2 on my staging environment. You throw up a pull request. Some developer is like, hey, that looks good, you're not going to break anything, it's just staging. And so then you just pull it, and you merge it in, and then you have this operator. If you're familiar with the operator pattern in Kubernetes, it's just pretty much a service that lives inside the cluster and does cool shit for you. And so this really cool shit that it does is it sees, hey, this Git repo just refreshed, either by pulling that repo and seeing a new update, or a Git webhook saying, hey, this Git repo updated. It looks at this, does a diff, and it does the kubectl apply. And then all of a sudden, now the state is all from this, right? And so you're like, oh, okay, cool. And you know, the operator manages the deployment, the rollout, all the business that needs to change. And yet, you get to see it happen all in Git, and it's a really cool thing. You know? And so now you're going to bring up, what about secrets? I can't store my secrets inside my Git repo. That's crazy. And it is crazy, right? But somebody else wrote a different operator. And so this is called the sealed secret operator. And so it's another operator that sits up there. You create a public-private key pair. Private key lives in the cluster, and we can talk about how secure that is. You can make this even cooler with Vault, whatever. Essentially, though, you have your secret locally. And then you do the sealing process on your local machine using the master key up on the cluster. And it creates a sealed secret file, which is just essentially just an encrypted secret. And then you can commit that to your Git repo. Then, whenever you run this, and you know, if you go back to here, I just created a new secret, added it to my config repo. The operator sees it and is like, hey, you have this sweet sealed secret, you know? I'm gonna use my sealed secret operator, unseal it with my private key that lives on the cluster, and now you just have a secret that lives on your Kubernetes cluster, committed to Git. It's kind of cool, you know? And so that's pretty much it. Here's some quick resources that you can kind of jump through. At Onyx, we're using Argo, which I think is probably one of the cooler solutions. Weave has one, but you have to pay for it, so that sucks. Customize is probably the coolest YAML templating out there. It's similar to Helm, but you can read it. Ambassador is a super awesome Ingress controller that I highly recommend everybody using. It uses Envoy behind the scenes, which is Istio. And you can find all this stuff if you just Google anything for our tech world, and you get an awesome list. So thanks.